All right, it's time for a demonstration of an acid-base reaction and how electrolytes are related to these reactions. I'm using a low-tech conductivity apparatus with a little pair of electrodes, copper electrodes separated by a little spacer, which you can see here. When I immerse these, into water, this is just distilled water in the beaker. Nothing is going to happen if I turn the switch and push the button. The light bulb has no glow. All right, so that's what we're expecting with water. Let's try it with some other solutions. Flip the switch back, lift up the electrodes. This is kind of a close quarters experiment, but bear with me. All right, so the first thing I'm going to test is sulfuric acid. This is 0.1 molar sulfuric acid in a beaker. And I'm going to take off the extra moisture from here just because I don't want any extra there. And I will put the electrodes down into the solution at the bottom of the beaker. And now if we flip the switch and push the button, ta-da! Uh-oh, now can we see it or not? Can we see the glowing light bulb? What do I have to do to show you the glowing light bulb? Uh-oh, I have to figure out something to try here. OK, now I've discovered the geometry that works. So now you can tell with the electrodes in the solution that is sulfuric acid at the moment, it has a very brightly glowing bulb. All right, test solution number one. We flip the switch, remove the electrodes from the solution, and test the other solution that I'm going to compare this time. The other solution, first I have to rinse it. I'm going to rinse the electrodes so you don't have any contamination from one solution to the next. Into just a little bit of water here in the beaker, and then I will totally immerse the electrodes in a bigger beaker of water just to make sure it's completely clean and to verify that there's no ions left in the solution or on contact with the electrodes. No glowing light bulb, the electrodes are clean. Pull up the electrodes again, remove the beaker. Test solution number two then is going to be barium hydroxide. I have a 0.1 molar solution of barium hydroxide. Again, I want to daub the extra liquid off of here because I don't need it. And then this solution says barium, oops, if you can see it, barium hydroxide, there you go. And we'll immerse the electrodes into the solution of barium hydroxide. My hand is out of the way, there we go. And flip the switch, oh, it is in the right spot. And indeed, there is the presence of ions, the light bulb glows. Now, what I want to do is I want to demonstrate what happens if I add the sulfuric acid to the barium hydroxide. This is going to take a few minutes, but we're going to be patient and see how that works. So the second beaker contains the sulfuric acid. And whoops, where's the label so you can read it? There you go. And I'm going to add it a little bit at a time to the solution that's of the barium hydroxide with the electrodes in. So I've got to hold my hands in the right spot. I'll put this over here then. Good. The light bulb is going to glow, and we're going to add sulfuric acid to the barium hydroxide. Both of those are strong electrolytes. The light bulb will continue to glow, and there are still ions present. But hopefully you'll notice there's something happening in the barium hydroxide solution. As I add sulfuric acid, the solution becomes cloudier and cloudier because the sulfuric acid is reacting with the barium hydroxide to make barium sulfate as the neutralization reaction proceeds. Now watch the light bulb as I add more sulfuric acid. I'll mix it a little bit. Notice the light bulb intensified. Oh, now it's getting dim. Whoa. As I add enough sulfuric acid, it's reacting with the barium hydroxide. The light bulb's gotten dimmer. I think you can tell that. And I'll add a little bit more. Oh, as I add it directly on the electrodes, it's bright. But then as I mix it, not so much light bulb. It's getting pretty dim there. Keep going. And add some more right on the electrodes. It goes brightly, but look at that. The light bulb is all but out. And contrary to how I tried it in class the other day, it didn't work as well. I'll add a little bit more. And I don't know if you can see it, but there's a very, very, very faint glow of the light bulb. Essentially, almost no electrons or ions, left in the solution. Oh, I squeezed it onto the electrodes again, and look at that. Absolutely no glow. No glow left at all. Apparently, all of the ions are reacted to make barium sulfate, and the second product is water. And there's nothing left to conduct electricity. What happens if I add more sulfuric acid? Well, I'm going to add some to the solution. I'll mix it up. Guess what? The light bulb's beginning to glow again, because now there's an excess of ions in the solution. Oh, maybe not quite. Wow. All right, keep trying. A little bit more. Add a little more. And the light bulb should return to being glowing because there are still ions present in the solution. So I've gone past the point where all of the ions from the barium hydroxide were reacted with the sulfuric acid, and now there was none left. But after adding this extra sulfuric acid, we have ions in the solution again, and the light bulb begins to glow. So notice also the color of the solution in the barium hydroxide beaker. Now it's combined with the sulfuric acid. It's very murky looking. That's the precipitate of the barium sulfate formed from that reaction with the sulfuric acid and barium hydroxide. All right, that's what I wanted you to see. It's a nice way of thinking about acid-base neutralization and how electrolytes demonstrate the presence, or the conductivity apparatus demonstrates the presence of electrolytes and ions in solution. I hope you find that helpful.